So in the previous video we saw how we could find the volume of a hollow cuboid, so this cuboid, using these centimeter cubes. So these are unit cubes that have a volume of 1 centimeter cube. And so by finding out how many such cubes can be fit into this cube, we found the volume of this cube. But this approach has some limitations. For example, this cannot be so. Let's say I wish to find the volume of this bottle here. So this is a empty bottle of vanilla extract, and let us say I wish to find the volume of this. The problem with that is if I open it up, I cannot fit it. So yeah, there you go. I cannot fill it up with these cubes, and even if I do, there will still be some space inside it left. That cannot be occupied by these centimeter cubes. That is because these have corners, while this has no corners. So yeah, but the point here is that you cannot use this approach to find the volume of things like these. So for this we need to do something else. Now for this, if you remember, we had the second interpretation or visualization of what volume is. So here what we can do is we can fill this up with water and find the volume of water that is required to fill this up. So you remember, right? Either we could just see how many centimeters cubes can I fit into anything to find its volume, or I can fill it up with water and find the volume of that water, because the volume of that water would be equal to the volume or the capacity of this object. Okay, so this approach should work for hollow things like this. So here I go and fill this up with some water, and yeah, there I go. I filled it completely with water. Now what I do is, so how do I measure the volume of this water? Well, wait, I'll just get the jug of water here. So I'll keep this aside for now. Now what I do is I carefully fit the cap onto this bottle. So this is completely filled with water. Now the volume of this water should be equal to the volume of the capacity of this bottle to the volume of this bottle. So what I do is I take one. So I'll just take one of these cubes, and yeah. So if you can see it, so this is a hollow cube here of dimension of volume 1 centimeter cube. So I'll see how many such cubes can I fill up with the water that I have inside this, and yeah, I'll just start, and you just watch it. Okay. So that's the first cube that I filled, and I'd like you all to count with me how many cubes I use. So this is the first one. Now let's start counting after this. I mean, including this one also. So this is one. Okay, so I've transferred almost all the water in this container into these small tubes and transferred them here. So in all, I think I took around 20 such small cubes. So the volume of the water that was inside this, obviously I have spilled some water outside also. So there might be some error in my calculations in this experiment. But basically the idea is that the volume of water that was inside this container was around 20 centimeter cube. Now at this moment I'd like to introduce another unit of volume that we use generally. For fluids we use the unit milliliters. So milliliters is the same as the centimeter cube. So 1 centimeter cube is also is exactly equal to 1 milliliter cube. So 1 milliliter cube. So 1 milliliter. Sorry. Is exactly equal to 1 centimeter cube. So the water that is, so if I fill this up, so this is exactly 1 ml of water. That much, okay. And this cube is 1 centimeter cube. So centimeter cube we generally use for both liquids and solids, but milliliters is generally used for fluids like water and milk. So for example, if you can check the bottle of maybe Coca-Cola, it says 250 ml or all that, or 250 ml or maybe 500 ml. So what that means is that if you have a 250 ml bottle that has 250 such cubes filled with Coca-Cola, that might be filled in that. So I can actually fill 250 such cubes with that amount of Coca-Cola contained in 250 ml in a 250 ml bottle. So yeah, and that is how we measure the volume of irregular objects that are hollow. And one small thing that I'd like to point out at this moment is that this was a very tiresome task, and I think we can use a shortcut at this moment. So what I can do is, here I have a weighing scale and switch it on. So this weighing scale will tell me the mass of anything that I put on it. Now what I can do is, so I'll carefully place 1, 2, 3. Wait, I'll just empty them completely. So I have placed these cubes here. Yeah. So the problem with the scale, so this is still showing me 0, is that this cannot measure anything less than 3 grams. So that's not a problem there. But what I can do is I can press this tear button here, and when I press that, it will neglect the mass that is already placed on this. So the mass that I've placed already on the plate is the mass of these 5 cubes. So when I press tear, it simply ignores that mass, and now it will only count the mass that I add after pressing the tear button. So now I'll just fill this bottle up with a bit of water and put on the cap. And now what I would like to show you is, when I fill these, so this won't be exact, but when I fill these cubes with water, so I'll just fill them up with. So I filled these 5 centimeter cubes with water, and what I can see here is I get 5 grams. So what that means is that the weight of, so this is the weight of only the water. Remember, so because I've pressed the tear button after I've placed the cubes, so I'm not including the weight of the mass of the cubes, and this is only including the mass of the water. So the mass of the water is 5 grams. And if you realize, we have 5 cubes, so which means we have 5 centimeter cubes of water, or rather 5 milliliters of water, and the mass of that is also 5 grams. So this is a very interesting and kind of magical result, so to speak, because the weight of water in grams is exactly equal to its volume in milliliters or in centimeter cube. So instead of measuring the volume by putting them in small cubes, or even we can use measuring cylinders for that matter. But another thing that can be done is, we can simply measure the mass of the water. So if, for example, if I get 5 grams, I know that is 5 milliliters, because the mass of water in grams is equal to its volume in milliliters. So that is only true for water. And why that is true is, I believe, is that is just a beautiful coincidence of nature. But yeah, that is something that happens. And yeah, even that's all. And that's it for this video. Yeah.